Okay, you guys, so we're going to talk quickly about 10.8, Chapter 10, Section 8, Geometric Probability. K is chosen at random, so it's point K, on the line AF. Find the probability that K is on the segment. All right, so the probability is, there's a simple, like when you're doing number line probability, like what's the chance on the number line? You take the absolute value of your 2 points it's the absolute value of the 2 points that you're looking at minus the absolute value of the points for the total line. So let me show you what that looks like. So for A to B, that's right here. The distance from A to B is going to be 3 minus 0. And the distance of the whole thing from A to F is 12 minus 0. It doesn't matter which one you put in first because you're taking the absolute value. I just like to put the bigger one in first, so when I'm minusing it, it's less work. 3 minus 0 is 3. 12 minus 0 is 12. 3 over 12 is 1/4. And then just for sake of probability, we like to do things in terms of percentages. So put 1 divided by 4, and then times it by 100 to find, oh, it's 25%. So the probability of landing point K being somewhere on line AB is 1 out of 4, or 25%. Let's do this 3 more times. So BD, B is at 3, D is at 8, so it's 8 minus 3. And we already know that the whole thing is going to be 12, so I will not do that calculation. 8 minus 3 is 5. 5 divided by 12 is 5/12. It doesn't reduce. And then we throw our calculator up and we go. 5 divided by 12 times 100. So it is 42%. So the probability is 5/12, or 42%. That our K is going to be between B and D. AE, A is at 0, E is at 10. 10 minus 0, we're still using AF, which has a total distance of 12. So we get 10, our probability is 10/12. Let's reduce that to 5/6, and then on our calculator, find the percent. 5 divided by 6 times 100 is 83%. So 83% chance we are going to land on AE. It's a long guy. It's a pretty big chance. All right, BF is 12 is F, 3 is B, and we know the whole distance is 12. 12 minus 3 is 9. 9/12 reduces to 3/4, and I know that one by heart. That is 75%. Okay. On the line segment, so here's a situation where we're given a problem and we have to figure out our own picture. On line segment QS, R is the midpoint. Okay, so let's draw that picture. QS, R is the midpoint. What is the probability that a randomly chosen point is on RS? So if you are like, tell me, is this weird because I won't have any numbers? We can make up numbers. So if we say Q is at 0 and S is at 10, where does R have to be in order to be the midpoint? It can be at 5. So then your problem would be, the probability is 5 minus 0 over 10 minus 0. And it would work if this was 100. It would work if this were 2. It would still give us the same probability of 1/2 or 50%. Okay, so anytime in math, when you get stuck without numbers and you're like, I don't know which direction to go, pick numbers that fit the scenario and push the math through. Example 3. You sell car stereos within the rectangular region. You are trying to decide how much money to spend on advertising for each side of town. What percent of advertising should go to the west side of town? Never eat shredded wheat. West side of town. So we're going to find the area of the whole thing and then the area. So when you get a shape and you're trying to find the probability, you take your smaller area and put it over your total area. So we are going to be hunting, let's do the total area first because that's going to be easier. So this shape is a rectangle. Anytime we do rectangles, we have base times height as our area. The base here is 2.25 plus 1.75. Well, that is 4. And the height here is 0.5. 4 times 0.5 is 2 miles square. So our total area is 2 square miles. Okay, our smaller area. For a right triangle, the smaller area has a formula of 1/2 base times height. And for a right triangle, the base here is 2.25 and the height is 0.5. We jam that into our calculator because who likes to multiply decimals together? So I got 0.5 times 2.25 times 0.5. Ooh, lots of 0.5s in that one. 0.5625. I know, don't judge me. I don't like to. I can copy and paste. I will do that all day. So square miles. Okay, so it's 0.5625. Okay, and let's find the percentage. Nope. Sorry, I times by 2 instead of 100. 28.125%. Should go on this west side of town. 28.25%. All right, beanbag toss. The following board has 4 congruent holes cut out of it, each with a radius of 0.5 feet. So let's, of course, write that in. What is the probability that a random beanbag toss will go through one of the holes? So this is an expertise. This is blind tossing. So we're going to go, the probability is the smaller area which is our 4 holes, over our large area, which is the rectangle. Okay, so let's go ahead and find the smaller. We did it before where we found the larger one first. Let's go ahead and find the larger one. So it is a rectangle, so that the area is base times height, which is 12. And then the smaller one, well, it's the area of a circle, so that is pi times radius squared, but there are 4 of them, so we have to multiply that by 4. And I'm going to get an approximate on this guy because it didn't say to keep it in radical form. Oh, surprisingly enough, the answer is 3.1. It's pi, 3.1 feet squared. So we are going to then give the percentage, 3.1 divided by 12. So that is 26%. All right, last one, the dart throwing. The bullseye has a 2-inch diameter all the way across. Each ring is 1.5 inches wide. Find the probability of hitting the bullseye with a random throw. So the bullseye, so we want, what's the total area of all of our circles? We have to add up, find the radius to find the total area. So it's going to be the bullseye area and the total area is this probability. So the bullseye area, the total area is going to be, this is a radius of 2, so this is a diameter of the bullseye of 2, so its radius, I'm going to split this up into 1 and 1. 1 here, 1 here. So we got 1.5 plus 1.5 is 3. 3 plus 1.5 is 4.5. 4.5 plus 1.5 is 6. So our total radius here is 6 plus the radius of the bullseye, which is 7. So pi times 7 squared. I'm going to keep my answer in terms of pi because we're talking circles and it'll make the area come out a little bit easier. So we got 49 pi for our total area. And then the bullseye area, it has a radius of 1, so it's pi times 1 squared, which is pi. So the probability of throwing a dart and hitting the bullseye is 1 out of 49, which is 2%. All right, now we're going to expand our horizons. Find the probability of hitting the shaded region. So we need the probability of shade, the first 3 circles. So the bullseye and then the second and third circle. So that's the shaded over the total. We know what the total is. It's 49 pi. The shaded is 1.5 plus 1.5 plus 1, which is 3 plus 1, which is 4. So this has a radius of 4. So our shaded region is going to have an area of pi times 4 squared, or 16 pi. So it is, the pi's cancel out, and the probability is 16 over 49. And if we put that in our calculators, we get 33% probability. Okay, so the way we sort this out is we take our area we want to find the probability for divided by the total area. Find those two areas and then divide them out. All right, you guys, go ahead and do our practice assignment from 10.8 and then come back here to check your answers. All right, and here's the answer key for the practice problems from 10.8.